Okay, we'll talk today again about functions, and I'll give a few examples to make things more clear. Let's use an example, a person and the house he lives. So the person can be considered as the first part of the function, and the place where he lives, the house, is the output. Now, many people can live in one house. That's no problem. So you take a list and you write down in the first column the name of 1,000 people, or 10,000, or a million, or whole Brooklyn. And the second column you write where they live. Now we have no problem if 100 people have the same address. It can be a huge complex building. That's considered a kosher function. It doesn't violate the rules of a function. So since the column A has the names, each name is unique name, and column B can have a lot of doubles. Can be actually can be in column B, or some homes also can have no parking at all. But besides the point, so column B can have addresses or nothing, and that will be a good function because there are no doubles on column A. However, let's say a person owns a few houses. He has apartment here, apartment there, all over the place. So now we cannot fill in on column B a few addresses. No, we can't do it. That's no good. Can we write the person's name on column A a few times and then put in column B a different address? No, also not. Just doing it, trying to get away with it. The bottom line is you cannot make anybody in column A, any item or any element, as they call it, in column A, have two matches in column B. So the person cannot have two houses. But come on, why can't a person have two houses? Something wrong with that. Let a person have 5 houses if he can afford it. So what do we do if we want to follow the rules of a function? We're very loyal to the rules of function, and we want to make a list of all the people in Brooklyn and all their houses. So we can get away with it with a tiny trick. We understand every person, let's say he has 5 houses, 6 houses. He has a house that he is there the most of the time, then there's secondary, then less. It's very unlikely that he is in 2 houses exactly the same amount of time throughout the year. Let's say in one house he is 6 months, other house 3 months, other 2 months, other 1 month, other 1 week. You can always figure out, always a few seconds theoretically, that he is in one house more than the other. Let's say even if he has 10 houses. So what we can do, make such a trick. Let's make like this. We take first one huge page, we write down all the people again, as I said, and all their primary houses, means the houses there that they are there the most. There's only one house that each person is there the most of the time. It's impossible, according to mathematics, that he should be in 2 houses the exact amount of seconds. Considered impossible according to probability. So that doesn't exist. So we have now next. The next list is going to be another piece of paper. You're going to have again all the names, and this is going to be a new function. Let's call it gx. First one is fx. This is gx. It doesn't matter how you call it. This is going to say each person in which house he is not what's his secondary residence, second to the most of the time. Now, the people that have only one house, for them, we could argue, this is up to everybody, he can make his own decision on this issue. We could argue that they do not belong on the list because they don't have a secondary, they only have one residence. So we have to make the list very short, only the richies that have two houses. We could say that. So that would mean that the second function is only defined on such people that have two houses. We could say otherwise too, but this is just arbitrary. It's just how you make up your mind. If you want to waste a lot of paper, then do it otherwise. If you want to make it more neat, then follow what I say. The second function is defined in a way that only somebody who owns two houses is included in this. Somebody else is totally not on this list. Actually, the person is there, but he doesn't have any. He's undefined, as they say. He's undefined. His output is undefined. So we have only the people that do have two houses, and then the second list of paper is going to say their secondary residence. So now, and then you understand yourself. People that have three houses, they're going to go on the third list. It gets smaller and smaller. The person that has 10 houses is going to be on the 10th list. It's going to be a tiny function. Only one person and one house. That's the place where he lives the least of all the 10 houses. We go to order from biggest to least. What did we accomplish here? We accomplished a very interesting thing. We make rules, and we try to follow strictly our rules. That's mathematics. It's trying to make rules and then to follow it. And sometimes it's very hard to follow the rules, or it sounds very crazy. But if you don't follow the rules, you fall into a pit. So you want to drive very safely, you got to take the very neat road. So the rule is, in order to get things in the right order, and not to get things mixed up, we always have, as I said, we'll recap it now. We always have in the box A can only have only one output in box B. You cannot shoot out two things. There can be many people in box A that shoot out the same result in box B, but box A, a person can only give out one house. That's what a function is. So in order to compensate for that problem, we create a second function, and you say, hello, don't worry about it, we'll record all your houses. You just have to give us a moment. We have to make a new list. That's going to be a new function. That's going to be called the function of people with their secondary residence, and you're going to be listed in that function. That is the end of the second recording. I just want to give one more example since the time is not up yet. That's going to be example of children in a school. Very similar. Every child goes to a school, and a lot of children go to the same school, so it's a perfect function. You take a list of children and you give them the second box, the school where they go, the name of the school. If a child goes to two schools, then you make this primary and a secondary school, exactly what I said in the houses. Everybody can figure that out themselves. Thank you for listening.